Hello and welcome to this intelligent briefing. I'm Ellen Flannery, content strategist at Linchpin Media, and today I speak to Andrew Froehlich, president of Westgate Networks, and Lisa Schwartz, director of business development and product marketing at AEM. We speak on the topic of data center cabling, discussing everything from the three main types of cabling to the biggest connectivity challenges faced by data center organizations. So to start us off, please can we introduce ourselves to audiences with your name, role, and company. So Andrew, why don't we start with you?
Sure, my name's Andrew Froehlich. I'm the founder of a company called Westgate Networks. We're a network IT consulting company. I'm also the founder of InfraMomentum, which is a marketing and IT strategy company.
Lisa?
Good morning. My name is Lisa Schwartz. I'm the Director of Product Marketing here at AEM. I have been in the test and measurement industry for about 30 years now, across a variety of different brands.
Brilliant. Andrew, can you kick us off by telling us what are the different types of data centers from a cabling perspective?
Sure. So when we're talking about cabling architectures, we're really talking about the physical cabling path between servers within the data center and the data center switching infrastructure. And the data center infrastructure obviously attaches to the larger corporate local area network or wide area network. Before running new cabling or testing existing cabling in the data center, it's really always a good idea to understand that cable plane architecture. The reason is that this information, it really helps the data center technician or the cable installer to understand how data flows within the data center and between applications and servers and storage devices. So the first and probably most traditional cable architecture is called the centralized cable layout. And this is usually found in smaller or older data centers. However, I run into them all the time. And this cabling layout is when data center switches are located in a single location within that data center. The reason that this was done traditionally is because switches used to be very, very expensive. So they used these large chassis switches, and it was just more cost effective to run all cabling within a single data center back to that single location. Cabling is typically run either under floors, if it's an elevated floor, or overhead in ladder racks. And so in this type of layout, the cabling is by far more than other data center architecture layouts because you're having to run cable from one end to a centralized location. This can obviously cause some issues from a cabling perspective because you have massive amounts of cabling coming into a single spot.
Can you tell us about some of the network connectivity challenges within these different types of data centers, and also how AEM can help test and or resolve these issues?
Yeah, so from a centralized cable perspective, the biggest challenge is just working with the massive amounts of cable that are either under the floor or overhead. What I've seen happen is a lot of the older cabling gets abandoned, but it never gets pulled out. So new cabling is laid on top of the older cabling, which causes all kinds of headaches. And inevitably what happens is somebody needs a specific fiber or copper cable, and they'll use an older one not knowing its capabilities, whether it's Cat 5e, Cat 6, whatever. And so there's all kinds of problems from a connectivity standpoint, from a PoE, how much PoE it can handle, and those types of problems. So, there's also difficulties when removing these types of cables because these cable runs can be very long, up to 100 meters for copper, and depending on the types of fiber transceivers you use, it can go even longer than that depending on the size of the data center. And really this leads into situations where the installed cable, you never really know what its capabilities are unless it's tested thoroughly, right? And so If older cabling is on top of newer cabling, it really becomes a complex issue of understanding what those capabilities are, and can you really trust that type of cabling?
Yeah, and thanks, Andrew. And I'll speak to the testing side of it. Gosh, lots of things to think about here. And, these days, I think data center managers are also having to put a little more focus on the proliferation of IoT connected devices. So we think about things like, the obvious things like cameras, wireless access points, but, there's building sensors, security systems, the list just goes on and on. And particularly in this type of data center layout that Andrew has described, the network owner is going to want to go into a cable reuse situation and be able to reuse that cabling for these applications that were never even conceptualized when that cable was initially deployed. So now we're running power over Ethernet. We're asking for very specific speeds across the cable. If we're thinking about devices that require, say, 2.5, 5, or 10 gig to run. So I'd say one of the first things we think about with validating that cabling is to certify it again. So one of the first things I would do is certify the cable. Cable certification is going to give one of the best validations, if you will, if that cable is going to be able to support the new intended applications. And as part of that certification, not only are you going to get a pass or a fail on the performance of the cable, but with some certification testers, it also gives you the ability to quickly understand in a very simple way just a listing that will list out, based on the performance of this cable, these are all of the speeds and application types, if you will, that this cable is going to be able to support. So that'd probably be one of the first things I would think about, is being able to certify the cable. But then we think about, as Andrew was saying, there's a lot of legacy cable in there, and you probably don't know what's connected to what. And so also having the ability to quickly understand from one end of the cable to the other, where does this cable go? What switch am I plugged into? What slot? What port? Am I on the right VLAN? Being able to have that level of information through really the same piece of test equipment that you just certified with is going to be a big time saver. And then as we think about the deployment of these IoT devices, a large percentage of them are going to get their power over Ethernet. So being able to measure actual power load, am I actually able to get the level of wattage I need out of the jack to support my device across this cable? So we think about certifying, we think about testing power load, we think about validating link speed. Is the cable going to be able to support the speed I need? And you can quickly see, traditionally, this might mean, oh my gosh, are we talking about this tester for this, and this tester to do that, and this tester to do this? And there's testers now available that are multi-function in nature, and they allow the user to easily shift between different kinds of tasks, particularly with these different types of data center layouts, switching between certification and then validation of these other things that I just mentioned.
Andrew, can you speak to the need for documentation and reporting of connectivity and cable performance, whether it be copper or fiber?
Sure. I'll address that, but let me handle the other two layouts first. So we talked about the centralized layout which was the most traditional form of that. Now we're talking about end of row layouts. So with an end of row layout, this is a much more modern approach to the centralized cabling architecture. And how this works is instead of centrally locating all of your switches in a single location within the data center, it kind of breaks out the switching architecture a little bit. So you have a distribution switching area, which is typically centralized, but then you break out smaller switches and place those into each individual data center row. So what this does is that the connectivity between the distribution switch network and the access switch network is typically static in nature, and that uses almost always it uses fiber optic connectivity, whether it's single mode or multi-mode fiber, and those run at speeds of 10 gigabits per second or higher, typically 40 or even 100 gigabits per second. And what this does is that it removes a lot of that cable glut that goes into a single area, because when you're connecting your servers to the network, you're now having to travel a much less distance because that switching infrastructure is in a single row. So this does free up a lot of the cable congestion issues within, compared to a centralized system. So there's a healthy mix of fiber optic cabling as well as copper cabling for connecting servers and other applications and services that the data center provides. And then, so the final one would be the top of rack layout. And with the top of rack layout, this further expands the network infrastructure. Instead of placing a network switch in each row of the data center, actually each individual rack receives its own switch. So again, you're further creating a situation where connectivity between the server and the network, that cable length is far smaller in distance. So swapping between cables and moving systems around makes it so much easier in an end of row layout, and that's why a lot of companies are moving to this model. In addition to that, it's the switching network in general is becoming cheaper and cheaper, while cabling is becoming more and more expensive. So to have that sort of situation where you only have to cable small distances can be a great cost savings benefit.
And then if I can add in there some of the, again, as we think about the testing, now, as you mentioned, Andrew, we're talking a little bit more about the fiber optic element.
Right.
So also being able to do at least a tier 1 certification on that fiber optic, again, to ensure it's going to support different kinds of applications, whether those are IoT related or not, but being able to support the fiber optic applications. And especially when we think about moves, adds, and changes and moving cables around, another really important element with fiber optic is also being able to essentially scope the fiber and being able to visually inspect the end of the fiber heads themselves. A lot of times we get tech support calls in, people having fiber problems, and they, can't understand what it is. And I have to say, probably over 90-95% of the time, if we have them unplug, clean the heads, scope it, the heads are just dirty and there's dirt on the cabling. So again, having flexibility in the piece of test equipment that you're using to expand into fiber optic is important. Another element of fiber optic I want to note, since you highlighted some fiber optic there, Andrew, is another technology that is starting to become more and more prevalent is hybrid powered fiber.
Right.
And with hybrid powered fiber, this is used in situations where you need to support power to a device. I'm going to use a camera out on a light pole in a parking lot as an example, or up on top of the building, a place that's really hard to run traditional electricity. But I know I'm going to connect to the network via fiber optic. And so I have got to be able again to test the connectivity. This time we're just talking fiber versus twisted pair copper, and I've got to provide power. So in this case, instead of talking about power over Ethernet, now I'm talking about DC power over fiber optic. So also think about having a capability and a strategy that allows you to do simultaneous Tier 1 fiber optic certification, as well as look at the DC resistance and actually measure the voltage on that cabling from the fiber perspective. Mm-hmm. The other thing I might mention is, as we continue to kind of talk about how, just with the proliferation of IoT devices, I think, and Andrew, correct me if I'm wrong, but I think that data center managers are having to do a lot more and expand a lot more into dealing with more and more types of end devices.
Absolutely.
And validating those.
Absolutely. So it used to be that PoE didn't exist within the data center, it wasn't needed. But now as we're seeing more and more, Wi-Fi being one, Wi-Fi is prevalent within data centers now. In addition to, network connected door controllers, smart lighting, all types of different sensors that is monitoring temperature, humidity, et cetera. All these things are connected to the network via Ethernet, and they all need power. So there's quite a bit of power over Ethernet going on in there. And so you have some challenges with massive amounts of cabling running PoE, and you get crosstalk problems and all types of situations that you have to troubleshoot for.
Yeah. And, in addition to, you made me think of it when you were talking about the crosstalk and being in these bundles, particularly when we're dealing with cable reuse. But another thing that is really critically important, especially if higher wattage things are being deployed, like digital lighting, where now I'm going to be running up to 90 watts of power over that cabling, it's going to heat up. So, testing for PoE connectivity, testing for PoE load, while that's critical, it is also important to be able to test for things like DC resistance unbalance, which is going to be able to measure if that cable is able to withstand interference per pair and pair to pair, to be able to continue to be able to fully support that voltage across the wire when it's a higher level of voltage and the cable's getting hot, because that introduces additional issues. Speaking of the Wi-Fi, and as we think about all of the different things, oh my gosh, now I have to have a Wi-Fi tester. Again, if you think about having test equipment that is multifunction in nature and specifically designed for these smart buildings, so I certified the cable, I might swap test heads, I switch over between copper and fiber. Now I need to do some validation on that Wi-Fi that you mentioned, Andrew.
Right. Yeah, it's important to note. I mean, Wi-Fi is so widely used for troubleshooting purposes within a data center. So you need to be able to have a tool that can see what SSIDs are available, to test the signal strength, to test roaming from one access point to another, to ensure that these technicians that are roaming around the data center troubleshooting on a daily basis have good connectivity.
Good connectivity, and as they're roaming, find the dreaded dead zones.
That's right. Yep. Absolutely.
Always an issue. And, and when we think about whether it's Wi-Fi connectivity or many of these other devices that are requiring a certain level of link speed to run, also having the ability to validate that link speed, specifically at the 2.5, the 5, and the 10 gig, which are the typical link speeds that these various devices are going to be requiring. You should have a strategy for being able to test signal to noise ratio, or SNR, which is really going to allow you to do a per pair validation of essentially, is my signal strong enough to get through the noise on the wire? Signal to noise ratio. So being able to get that validation, yep, on every pair, I can get the link speed I need. If your test equipment is able to even request load from the PoE, the device that's providing the PoE, a PSE, and midspan, even better. Essentially, you're trying to stress the wire by pushing traffic and power load on the wire simultaneously, really trying to put it under a stress condition, and then measure signal to noise ratio at every link speed across every pair. That's going to give the data center manager confidence that the various applications that they're going to try to deploy are going to support the various devices.
Right, right. Yeah, and speaking of confidence, we'll talk about the reporting needs for the data center, right? So, it used to be that cable installers would just come in and install the cables and walk away, right? More and more companies now are requiring some sort of proof that tests were run to validate and to certify the cabling, right? So from an end customer perspective, it provides them proof of quality that the installation was done properly. It also protects the installer, right? So the installer can go back to the reports and say, here's the data that we did when the test was completed, once the install was done. And it also, helps supports manufacturers' warranties on the cabling as well. So Lisa, what types of reporting do you see that people are wanting most?
Yeah, well, you're right on there. So there is the traditional, twisted pair copper cable certification report, as well as fiber optic. If I am installing the cable, and I'm an installer who's providing warranty, or I want warranty support from my cable manufacturer, those printed reports are critical from that perspective. But also think about for the network owner. They installed the cable, they gave me these reports, they walked away. Now I'm starting to deploy all of these devices and something's not working. Well, the first thing I might do is reference back to those reports. I want to make sure they tested to Cat 6A or whatever standard that I required, and did they all pass? If I have test equipment myself that is also able to certify, I can go back and do another certification test to see if something changed from the perspective of the performance of the cable. If all looks good there, now I need to start looking in some other areas. And with all of these different kinds of technologies that are coming upon us with smart buildings, having the ability to get printed reports beyond copper fiber certification is becoming more critical. And what I'm getting at there is, I talked about that signal to noise ratio measurement, and I talked about power load. Well, think about having the ability to get a printed report that shows me per link what is my signal to noise ratio, and being able to see the headroom across every pair at every link speed, and what was the power load on the wire. That is important. And then also being able to get a printed report on what is my network performance and network connectivity. So having printed reports on my network connectivity, having that data at your fingertips can really help with moves, adds, and changes, troubleshooting, things like that. So
yeah, great points.
Reporting is pretty critical.
Great.
So thank you both for joining me today for this interview. It's been really interesting.
Great. Thank you very much.
Thank you.
Thank you.